Hi everyone, and welcome to our course From Basic to Brilliance, Mastering CST Antenna Design's Fundamentals. This is Antenna Design Lecture number 1, where we will exclusively focus on antenna designing. In this lecture, we will discuss antennas, importantly the parameters of antenna, and the difference between HFSS and CST Studio. Now I am heading towards the lecture. In this case, the CST versus HFSS will discuss what is the difference between CST and HFSS antenna design. In CST, we have computer simulation technology, and in case of HFSS, we have high frequency structure simulator. In case of CST, it is based on finite integration techniques. The techniques used in simulating antenna is the finite integration technique. CST is very popular among antenna designing due to its high simulation accuracy and fast response. So in case of HFSS, the algorithm used is the finite element method, which is FEM. Now moving towards important parameter of antenna design. Now these are some of the important RF parameters. The first one is S parameter, followed by VSWR, and then the gain. Now these are some of the important parameters that highlighted in the RF parameter for designing the CST in CST or in case of HFSS. The first one is S parameter. So the S parameter describes the input-output relation between port and terminal in the electrical system. So why do we use S parameters? Specifically at high frequencies, it becomes essential to describe a given network in terms of waves rather than voltage and current. Thus, the S parameter we use power waves. In RF design, we cannot use other parameters for analysis such as Z, Y, H, C, etc. as we cannot perform short circuit and open circuit analysis, as it is not feasible here. Furthermore, the S parameter is also referred to as scattering parameters. It is also a mathematical representation of how RF energy propagates in the multi-port network. Lastly, these are the scattering parameters, which are also called as S parameters, namely S11, S12, S21, and S22. Then S11 and S22 have the meaning of reflection coefficients. Now these two are reflection coefficients and tells about the reflection of antenna, indicating how much power is transmitted, evolved, or reflected from the antenna. S21 and S12 tells about the transmission coefficient. Now these are the transmission coefficients of antenna. If we have two-port system, then we observe all these parameters as S11, S12, S21, and S22. But in case of just one-port system, we only observe the S11 parameter in the design. Moving towards the S11 parameter, this is the input port voltage reflection coefficient. As you seeing, this is the input port reflection coefficient. As you have seen, this is the input port voltage reflection coefficient. As mentioned earlier, the S11 and S22 represent the reflection coefficients. Therefore, S11 serves as the voltage reflection coefficient, which is the most commonly referenced and utilized parameter concerning antennas. S11 is also known as return loss, indicating amount of power radiated from the antenna, and is sometimes denoted as gamma or return loss. This is the input voltage reflection coefficient. If the reflected power radio 1 is trying to deliver to antenna 1, it tells us how much of the signal is reflected to receive after striking the antenna. Now, I have my antenna system This is port 1 with antenna 1 and this is port 2 with antenna 2. Now, the power delivered to antenna 1 through radio 1 are port 1 and the reflected power delivered from antenna 1 through port 1 are the S11 parameters. They describes how much signal is reflected after striking the antenna. Now, the most useful antenna parameter for checking how much power is transmitted is the S11 parameter, which tells about the power transmitted and reflected. This is a crucial point regarding the S11 parameters. Now, one important point is that the S11 parameter graph should be less than -10 dB. This condition shows that more than almost 90% of the power is transmitted and only 10% is reflected. So, in an ideal case, the graph of the S11 parameter, the reflection coefficient should be less than -10 dB. This condition indicates that antenna transmits 90% and reflects only 10% of the power. However, if S11 is between -9 dB and -8 dB, then the transmission is reduced and the reflection is increased. At -3 dB, there will be a 50% transmission as well as 50% reflection. So, another condition indicates that if the S11 parameter graph is at -3 dB, then the reflection and transmission would be 50%, indicating that antenna's reflection and transmissions are equal. Now, moving towards the S22 parameters. This is the output port voltage reflection coefficient. If we have two-port system, then the reflection coefficient at the second port is S22 parameters. It reflects the power radio 2 is trying to deliver to antenna 2. So this is port 1 with antenna 1 and this is port 2 with antenna 2. Now, the reflected power that is delivered to antenna 2 through port 2 is the S22 parameter. It reflects the power delivered to antenna through port 2. The S22 is also sometimes called as the output reflection coefficient. Here, in this case, the S11 and S22 parameters provides us with the following information: return loss or reflection coefficient, impedance, admittance, and VSWR of input and output ports. Now, after this S22 parameter, which is also called the impedance, admittance, VSWR, return loss, we will discuss the S12 parameters. The S12 parameters is also called the reverse voltage gain. S12 parameter is the reverse, indicating the power from radio 2 is delivered to antenna 1 and from radio 1 to radio 2. To understand better, let's consider an example. This is the antenna 1 with port 1 and antenna 2 with port 2. Now the power from radio 2, which is delivered to antenna 1, is the S12 parameter. So now the S12 parameter, this is the forward voltage gain, and the last one being the reverse voltage gain. The S21 parameter is the forward voltage gain in case of two-port system, which is the transmission coefficient. It represents the power received at antenna 2 relative to power input to antenna 1. Now I am considering an example. This is port 1 with antenna 1 and this is port 2 with antenna 2. Now the power received at antenna 2 relative to input port of antenna 1 is S21. this would be S21. Now I am considering again the more interface characteristics of S21. It tells us how much of the signal is transmitted into the surface and mostly used in EBG or FSS structures. Both S21 and S12 parameters are used in EBG. The EBG is the electromagnetic band gap and FSS main frequency selective surface structures to check how much of the signal is absorbed by them. S12 and S21 provides us useful information. These provides us with the gain or loss and insertion loss, phase and group velocity and group delay. Now, this is the discussion about S parameters that are S11, S22, S21 and S12. Now I am considering all the parameters in one diagram. Now let's suppose that it is two-port system in which this is the port 1 with antenna 1 and this is the port 2 with antenna 2. Now the reflected power from antenna 1 would be the S11 parameter and also the reflected power or the reflected coefficient from antenna 2 would be S22 parameters. In other words, the reflected power from antenna 2 would be the S22. Similarly, the power transferred from port 1 to port 2 of antenna 2 would be the S21 parameter. And the power transferred from port 2 to port 1, it will be the S12 parameter. Now after the detailed explanation of S21 and S12 parameters, now after the discussion of S12 and S21, we will look into this diagram. In this diagram, we have one incident power and the other one is the reflected power. The reflected power refers to that power which is not absorbed by the system, but it is reflected back. Now the insertion loss would be the ratio of the transmitted power and the incident power. And the return loss would be the ratio of reflected power over the incident power. So by this system, we come to know about the idea of insertion loss and the return loss of the antenna system. Now we will discuss another parameter. This is the VSWR. The VSWR stands for voltage standing wave ratio. This is the measure of how efficiently the radiated power is transmitted through the transmission line or the antenna. The VSWR, which is actually the voltage standing wave ratio, it is also a measure of the reflected standing waves along the feeder. The voltage standing wave ratio is an indication of the amount of mismatch between the antenna and the feed line connected to it. Let's suppose we have antenna and this one is the feed line. So the mismatch between antenna and the feed line would be the VSWR. The range of VSWR is from 1 to infinity and the VSWR value under 2 is suitable for most of the antenna applications. So if the VSWR value is under 2, the antenna can be considered to have a good match. If the value of the VSWR is 2 or under 2, then it shows that its impedance is very well matched with the transmission line of the antenna. And in other cases, when someone says that his antenna is poorly matched, it often means that the VSWR value exceeds 2 for a frequency of interest. So, if someone says that the antenna impedance is not met or very poorly matched, then it means that the VSWR is above 2. It would be 3, 4, 5, 6, but for the very good match, it should be 2 or less than 2. Now, what is the gain of antenna? It describes how much power is transmitted in the desired direction compared to that of an isotropic antenna. Transmitting antenna with 3 dB gain means that the power received far from the antenna will be 3 dB higher, twice as much as that which would be received from the lossless isotropic antenna with the same input power. Now moving towards the RCS. RCS stands for radar cross section. RCS for the detectability of an object by the radar. It is also the ability of an object to reflect radar signal in the direction of its receiver. A large RCS value indicates that an object is easily detectable. And what is the bandwidth? Now, the bandwidth is the range of frequencies over which an antenna works effectively, or it would be the range of the wavelength. Some antennas have a broader bandwidth. The broader the bandwidth, the greater the range of different radio waves you can pick up. Now, if the bandwidth is broader, then it means that the range you can see would also be broader. So this was all the discussion about our first lecture about the antenna designing. So if you have any query or if you have any question, you may contact us or you can send us email. Or if you want to ask some question or if you have any misunderstanding or any type of question, you may contact us by our email. In the upcoming next lecture, we will design antenna and we will learn about the CST Studio, how to design antenna in the CST Studio. Until then, goodbye and best of luck.